Effect of solidification parameters on the amount of eutectic and secondary arm spacing of Al(7Wt%C) alloy solidified under microgravity. An experimental analysis by Andras Roos, Arnold Ronafoli, Hughes Lee, Nathalie Manjlink-Noel, Gerhard Zimmermann, Henry Nguyethi, Maria Sveda and Zsolt Wiers. This chapter highlights the effect of G and V on the secondary dendrite arm spacing, stars, in purely diffusion circumstances, analyzed the thermal data of the experiments in detail, and take into account the macrogravity caused by the diffusion of C from the initial mushy zone during the homogenization step of experiments. During the solidification of hypoeutectic alloy, like Al(7%C), density difference develops in the melt generated by concentration and temperature difference. On Earth, as an effect of this density difference, the melt can flow due to gravity affecting the solidified microstructure. The developing meso and microstructures are also significantly affected by the melt flow occurring during the solidification processes in different casting technologies. This melt flow can be eliminated in a microgravity environment, which then makes it possible to examine the solidification process under conditions of pure diffusion. In the Materials Science Lab, MSL, on board the International Space Station, ISS, 4 solidification experiments were conducted on grain-refined and non-grain-refined Al(7Wt%C) alloy to investigate the effects of the solidification parameters, solid-liquid front velocity V, temperature gradient G, on the dendritic microstructures and the grain structure. A detailed analysis of the grain structure was conducted in a few previous articles. The macrogravity was calculated by the finite different method. Because the steady-state solidification conditions were never reached, the solidification process was characterized by the average front velocity and temperature gradient. It is shown that steady-state solidification conditions are never reached. At a given sample position, the velocity of the solid liquid SL and the eutectic liquid EL fronts and the temperature gradient at the two fronts are different. Then, the solidification process can be characterized by the average front velocity and average temperature gradient. Thank you for watching this video. Please subscribe our channel for watch more scientific research videos.